Hi students, this is Mr. Yao. In this lesson, we are going to talk about 2.3 rational exponents combined. So it's basically a combination of the previous lesson where we learned about rational exponents and the lesson before that where we reviewed all the exponential properties. So there you go. Let's have some prior knowledge first. Question A, whenever you have an exponent outside parentheses, we need to distribute. And that 243 still has a first power on top of it, so it also gets a 6 to the also get a 6 over 5 power. So 243 to the 6th fifth power times m to the 5 times 6th fifth power. This is simple, it's just going to become m to the 6th power. We need to deal with this number. You can choose to type the whole thing into your calculator, or some question will ask you to do deal with a number like this without a calculator. So let's see how we can do that. Whenever you have a number like this, you have two ways to write it. You can either keep the 6th power and put it completely under the root, then move the denominator into the index, or you can just keep the number itself under the radical sign, and then the whole thing raised to the 6th power. So you can see if we write that as the first one, 246 to the 6th power is a pretty big number that we can't just do it in our head. And then don't even mention taking a fifth root of that. However, the second way of writing it, we can easily think of the fifth root of 243. If you struggle to think about that is, so when you try to figure out what is the fifth root of 243 without a calculator, you're basically thinking a number raised to the fifth power equals 243. 243 is not a big number, so there's no way this number itself is big. So in fact, that number is just 3. So you're actually dealing with 3 to the 6th power. And 3 to the 6th power is, well, 3 to the 4th power is 81, times another 3 is 243, times another 3 is 729. There you go. That's question A. Question B, same thing, 64 to the negative 1/6 power. You got to distribute the power on the outside of the parenthesis first. Then n to the 12 times negative 1/6 power. So the whole thing becomes, the first one we already know is going to be moved to the bottom of the fraction, but let's deal with it. So first is going to become a 1 over 64 to the 1/6 power, and then you're actually just dealing with that. It's a 6th root of 64. So in other words, a number to the 6th power is 64. That number itself is a 2. So this is 1/2. And then this part, the second part, becomes n to the negative 2 power, which means n is also going to be going to the bottom of the fraction. Put them together, the whole thing is 1 over 2n squared. Next, we see has a third root, so we're going to move that to the denominator of the power of the exponent. So we have 5n, but since 5n is altogether under the root, make sure they are inside the parentheses, to the 5 over 3 power. Now, you have two different ways. If the question allows you to have a negative exponent, you can choose to change the 1 over into a negative exponent, or you are still going to have to keep it as 5n to the 5/3 power. If the question says, make sure your exponents are positive. So these are two different options. Okay, D, 10n is under the root, so they're going to stay inside the parentheses. And then 4 is the exponent on the outside. The root 3 becomes a denominator of the power. So there you go. These are things we have learned previously. Now, like I was saying at the beginning, this lesson is basically a combination of the previous two lessons, so it's not entirely new. And if you are consistent on trying to simplify some of the expressions, go for it. But if you have trouble with them, you always make little mistakes, then we have the same recommended procedure that you can follow. But the rule is the answer can only contain positive exponents. So firstly, the procedure you're going to distribute, because we got to get rid of the parentheses. So power rule to distribute all the exponents outside. And when we say power rule, that means you multiply the exponents. And when you distribute, make sure you distribute onto everything. And when we say everything, it'll also include the numbers inside the parentheses. And if you see a negative sign, and if you have trouble with it, treat it as a -1. Okay, next, we're going to cross out all the 0 exponents because they don't matter. They don't change anything. Next, we're going to flip all the negative exponents using the negative rule. That means if it's on the top of the fraction, it's going to go to the bottom of the fraction. If it's already on the bottom, then it's going to go to the top of the fraction. Lastly, we're going to simplify the numbers together and deal with one variable at a time. Okay, of course, these are the recommended procedure. A lot of time when you have parentheses and then you still have a power on the outside, you can totally simplify it inside the parentheses first before you deal with the power rule. So whichever way works for you, as long as you are very consistent to deal with some of the more complicated questions. So let's get into the examples. There are 16 examples, so you can pause anywhere and try the example by yourself and then come back to check the answers. So here's example 1. Just by looking, you see a negative exponent, so sure, you can actually flip it to the bottom of the fraction. But at the same time, since the whole thing is being multiplied, you should know very clear that you are supposed to add the exponents. Since we have a 2 and a negative 1/4, 2 is greater than negative 1/4, and that means even if we add them together, we're still going to end up with a positive exponent, so we don't have to flip that negative. We can just add them together. So it's going to be 2 plus 1/4 as the exponent, leaving the 4 in the front. Simplify it. 4x to the 7/4. Oh, no, sorry, it's a 2 minus, so it's 7/4. There we go. Okay, that's example 1. Example 2, we gotta distribute the second part. So that part is going to become 81 to the negative 1/4 power and n to the negative 1/4 power. Again, you can choose to type this into your calculator to get an answer, or you can choose to deal with it just by hand. Negative exponent means you flip to the bottom of the fraction. So you're actually dealing with 81 to the 1/4 power, which means you're dealing with 4th root of 81, and that is going to be 1/3. So this alone is 1/3, and that. As for the n part, well, we can actually combine all the exponents together. So we currently have 3n to the 3/2 power times 1/3 n to the negative 1/4 power. You can clearly see the 3 times the 1/3 is just a 1, so you are just dealing with 3/2 minus 1/4, and that will give you n to the 5/4 power. That's example 2. Example 3, all you need to do is just multiply the exponents because there's only one variable with a power rule. 2/3 times 3/4. You can choose to multiply the top and the bottom and then simplify the fraction, or you can choose to cross cancel. So 3 and the 2/4 simplifies to be a 1 and 2. So final answer, 8 to the 1/2 power. That is example 3. Moving on, example 4. Power rule, because we have parentheses, so 125 to the 2/3 power, then x to the 9 times 2/3 power. First, you got to deal with that number. It is the same as 125 taking a cube root, because the 3 is the denominator, and then we square it. A number to the 3rd power is 125. That number is 5. So this part is just 5 squared, which is 25. As for the second part, for the x, is going to be x to the 9 times 2/3 is 6. So final answer, 25 x to the 6 power. Example 5. Well, typically, whenever you have a radical, you are going to need to change into a rational exponent so that we can deal with all the rational exponents together. So this basically is a little 2 there, which means the square root of x becomes x to the 1/2 power times x to the 3/4 power. We're going to add the exponents. So 1/2 plus 3/4 simplifies to be x to the 5/4. Example 6, distribute the power first. 81 to the negative 1/2 power, and then p to the 4 times negative 1/2 power. Let's deal with that first part. Because the negative exponent, the whole thing could be flipped to the bottom of the fraction, so it's actually 81 to the 1/2 power on the bottom of the fraction. I'm going to rewrite it. It's actually square root of 81, which you should know. That is just 9, so the first part becomes 1/9. The second part, 4 times negative 1/2 is the negative 2, so that is p to the negative 2 power, which simplifies to be 1 over p squared. So altogether, 1 over 9 p squared. Because 9 is on the bottom, p squared is on the bottom, we just put them together on the bottom of the fraction. That is example 6. Moving on, example 7. Numbers need to be multiplied together, so the 2 and the 3 together becomes a 6. As for the x and the y in the front, they both get a first power, so it's x to the 1 plus 7/4 and y to the 1 plus 1/2. Simplify, 6 x to the 11 over 4th power and y to the 3/2 power. That is example 7. Example 8. That's a 1 on the top. So you should easily know 1 is bigger than 1/2, 2 is bigger than 3/2. So everything happens on the top of the fraction. Since we need to keep positive exponents, we just take the bigger one, subtract the smaller one. So it's actually x to the 1 minus 1/2 and y to the 2 minus 3/2. The 3 is still on the bottom. The whole thing simplifies to be x to the 1/2, y to the 1/2 over 3. There you go. That's example 8. Moving on, example 9. That's the first power. We can see we have some negative exponents. There's no power rule, so we can already start flipping them around. So x to the negative 1/2 power goes to the top, becomes x to the 1/2 power. Y to the negative 1 power, go to the top, becomes y to the first power. Then we just combine them. The 4, of course, stays on the bottom. So the 4 stays on the bottom, the top. 3/2 and 1/2 together is x squared. Y to the first and y to the first together, y squared. That's example 9. Example 10, we have parentheses, so we do need to deal with the power rule first. So that goes in and that goes in with the 1 on top of the u. So it's u to the 1 times 3/2 and v to the 3/2 times 3/2. And then we have another set of parentheses, so it's v to the negative 3/4 times negative 1/2. So we have u to the 3/2, v to the 9/4, and then this one on the back is v to the, that is 3/8. Okay, we're going to put everything together because they're both base v, so we can add the exponents. The u part is not affected. The v 9/4 plus 3/8 together is 21/8. That is example 10. Moving on, example 11 and 12. So like I will say again, I do recommend you pause before I talk about the questions. Try them by yourself. Since these are not exactly new, it is just working with fractions. That's making the question a bit more complicated. But try them by yourself first, then come back and check the answers. Okay, so here they're together. Well, they have the parentheses, so we're going to distribute the power. Y to the 4/3, x to the 2 times 4/3 is basically 8/3. On the bottom, we have y squared. X to the 0 power is already gone because that doesn't change anything. Y to the negative 2 power will be flipped to the top, become a y squared. And then you can see the top and the bottom both have a y squared. So without actually combining them, if they're exactly the same, I'm just going to cancel them already. So final answer, x to the 8/3 and y to the 4/3. That's example 11. Example 12. Like I was saying during the procedure, you can choose to distribute onto everything, then simplify, or you can choose to simplify inside the parentheses already before you actually do the distribution. So first, I have x on the top, a 5/3, and a 1. But then this x to the 1/2 power is on the bottom, but since it's smaller than the top, it's still going to be moved to the top with a subtraction. Then the y is, we have a 2 and a 1/2. The whole thing is to the negative 1/4 power. Let me simplify inside the parentheses first. We got x to the, that's a 5/3 plus 1 is an 8/3 minus 1/2. It's basically 16/6 minus 3/6. So that will give you a 13/6. As for the y part, 2 plus 1/2, that is 5/2. But the whole thing is multiplied with a negative 1/4. So now let's distribute. It's going to become x to the negative 13/24 and y to the negative 5/8. Since they're both negative exponents, I'm going to flip them both to the bottom of the fraction. Final answer, 1 over x to the 13/24, y to the 5/8. That is example 12. Moving on, example 13. Same thing. I'm going to deal with the inside the parentheses first. The power, 0 powers, they are gone. As for the rest, we're going to see which number is bigger. So first, u to the 4/3 on the top, u to the 1/2 on the bottom. 4/3 is bigger, so it's going to stay on the top. 4/3 minus 1/2. Then we have v to the negative 2 on the top and negative 3/4 on the bottom. Because they're both negative numbers, so even though you might think, oh, 2 is bigger, but since they're both negative, it's actually negative 3/4 that's bigger. So the whole thing will go to the bottom. So it's v to the negative 3/4. Since you're subtracting a negative 2, that has become a plus 2. The whole thing to the 1/3 power. Okay, keep simplifying. The top is going to become u to the 5/6 power, and the bottom is going to become v to the, it's a negative 3/4 plus 2. That is a 5/4. That whole thing times is raised to the 1/3 power. So now we can distribute the power. Final answer, u to the 5 over 18 and v to the 5 over 12. There you go. That's number 13. And 14, cross out the 0 power. Oh, even though we have parentheses, it's a 0 power outside, so the whole thing is just gone. Next, let's look at the negative exponents. We have a negative m on the top, that's going to go to the bottom, m to the 5/4. We have n on the bottom, that's going to go to the top, and to the 3/2. There's no other n anymore, so it's just going to be n to the 3/2 power. As for the bottom, 1/2 and 5/4 together is 7/4. So there you go. That is example 14. Last two, example 15. First, 0 exponent, we don't need it. And then this whole thing is just going to become x to the 7/8 power. So we just simplified it. Now we can start moving things around. Y to the -1, come to the bottom. Y to the -3, come to the top. X to the -2, come to the bottom. And then let's simplify. We have x to the 4/3 on the top, the bottom 7/8, and the 2 together is 23/8. As for the y, we have a y cube on the top and a y first on the bottom. That already becomes y squared. And we still have a 2/3 on the top, so it's going to be y to the 8/3. Now let's just simplify the x part. The bottom is bigger than the top, so it's actually a subtraction that stays on the bottom. 23/8 minus 4/3. You can either type in your calculator and get a fraction, or let's think about it. They both have a common denominator 24. So the first thing will actually become 69/24 minus 32/24. So final answer, x to the 37/24 power on the bottom, y to the 8/3 power on the top. Last one, example 16. Cross out the 0 power. We do need to deal with the parentheses. So let's copy everything down on the top. As for the bottom, -3 times -4/3 is a +4. b to the -1/4 times a -4/3 is b to the 1/3. And then the top, they're both negative, so move them to the bottom, to the 3/4. That leaves a 1 on the top. Oh wait, yeah, that leaves a 1 on the top. Okay, so let's simplify. 4 and 1/2, that is just 9/2. As for the b, 1/3 plus 3/4. They can both become 12, so it's actually 4/12 plus 9/12. The whole thing is 13/12. And that is example 16. So as you may notice already, everything is very similar to what we have learned in 2.1, just the numbers are more complicated. But as long as you follow the procedure and do your corrections correctly, they shouldn't be too bad. That is everything for 2.3. Thank you.